Okay, Algebra 2, we're on our last lesson in our Chapter 9, where we are finding the angle measurements and we are finding the side lengths of triangles using our law of sines and now the law of cosines. The law of sines works to solve AAS, ASA, and SSA triangles. There's not enough information in SSS or SAS triangles to start solving the triangles using the law of sines. To solve SAS and SSS triangles, the first step will be to use the law of cosines. So you'll see in a minute why we have to start some of these problems using our law of cosines. And it will be for the types of problems here that we see where we're given SSS triangles or SAS, because we'll try to use the law of sines and it won't work. And so we'll defer to the law of cosines. But let's take a look at the law of cosines as a first step. So here's our key concept, and yes, this needs to be on your paper. For triangle ABC, the law of cosines reads this way. If we start with a squared will be equal to b squared plus c squared, and that looks like the Pythagorean theorem it is, minus 2bc times the cosine of a. So the Pythagorean theorem is actually a very special instance of our law of cosines. So this part in the Pythagorean theorem actually is 0. So I remember each one of these by noting that whatever letter we start with, we're going to be equal to the other two letters squared and added. We're going to subtract off twice whatever these letters are, times the cosine of whatever this letter is. That's how I remember it. All right, so b squared then will be equal to the other two letters squared and added, a squared plus c squared, minus 2 times ac, the same two letters, times the cosine of b, which matches this b. Finally, c squared is equal to the other two letters, a squared plus b squared, added and squared, minus twice the same two letters, times a times b, times the cosine of c, which matches this c. You can always refer back to this, because it'll take a little bit of time for that really to stick in your brain. So there's your reference for how the law of cosines works. So let's go ahead and look at example 1, solve a triangle for the SAS case. There will only be one triangle possible because if this angle is included in between these two sides, there's no other possible way the triangle can be drawn other than put this side, this angle, this side, and the rest of it will fall into place with no other possible ways it can be drawn. So for each of these triangles we're working with today, SAS and SSS, there will only be one possible triangle. All right, so you're given this information. B is 34 degrees, A is 11, C is 14. And so we know about the law of sines. Why wouldn't we use it here? Well, here's the problem. If we did sine of B over B, we don't know what B is. And we say, okay, that's fine. Then let's go ahead and go with sine of A over A. But oh, wait a minute. Then we would have two variables and two unknowns. Well, what about sine of C over C? Oh, again, we don't know what our C is. So when we try to use the law of sines, we can set up proportions that are true. The problem is we'll have more than one unknown, and we can't solve for one unknown, for both unknowns in one equation. So that's why we need a different way of approaching this, and the law of cosines is the way that will work beautifully for us. So what we do is, when we're using the law of cosines in our SAS case, we find the side that we don't know yet, B, and that determines which one of the three ways that the law of cosines can be written. That determines which way we're going to use. We're going to use the b squared way because we don't know b. So in an SAS case, whatever letter you don't know for the side length, that's the letter you're going to start with. So we'll start with b squared equals a squared plus c squared minus 2ac times the cosine of b, and that just comes right off of our law of cosines that we wrote down earlier. Now we plug all the numbers in. We're solving for b, so we'll leave this b squared. And then our a squared is 11 squared plus 14 squared for c squared minus 2 times a is 11, c is 14, plugging in a and c. And the cosine of b is the cosine of 34 degrees. Then we set about simplifying all of this to make it easier to put into our calculator. We could put it all in our calculator at this point, but we're likely to make some mistakes because there's so much stuff to put in. So I'm going to simplify what I can. 11 squared is 121, 14 squared is 196. 2 times 11 times 14 is 308. I'll leave the cosine of 34 degrees for right now. And then I'll add 121 plus 196 and get 317. And I'll leave the minus 308 times the cosine of 34 degrees. At this point, I will put this all into my calculator to find my b squared. 317 minus 308 times the cosine of 34 degrees will give me this on my display. It'll be an irrational number. It will continue on. At this point, I will just leave this in my calculator, and I'll take the square root of this number to get it down to b, and I'll see this on my display, 7.8521607, da 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 da. And then I'll go ahead and round that off to 2 decimal places. The nearest hundredth, b is equal to 7.85. Okay, so now we know what b is. We know all 3 sides, and we know 1 angle. We could continue using the law of cosines. It wouldn't be wrong to, but you can see the law of cosines is a little more complicated to use than the law of sines. So at this point, since I know my b and I can set up my ratio, sine of b over b is equal to my sine of c over 14, or alternatively sine of 34 over b is equal to sine of a over 11. I have enough information for using the law of sines at this point. So that's what I'm going to do next. I'm going to use the law of sines and set up my law of sines equation, because I know this angle, sine of 34 degrees over 7.85, because that's what I just figured out the b is equal to sine of a we don't know yet, over 11. And then I'm going to solve this for a. So I'll use cross products. That will give me 7.85 times the sine of a equals 11 times the sine of 34. Dividing both sides by 7.85 and throwing that on my calculator, I'll see that the sine of a is equal to 0.78358, blah, 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 blah. And then I'll use my inverse sign to find my a. So sine inverse of 0.78358 is equal to a. My calculator will tell me 51.5897 and some other digits is equal to a. Rounding that off to the nearest hundredth gives me 51.59 degrees. Okay, so I have now figured out 2 pieces of information. I got my missing side b, and I have angle A. Now I could use either the law of cosines or the law of sines at this point, but that would be way more complicated than necessary. I know 2 of the angles, and I don't know the third angle, so I can say, well, the sum of all 3 of those angles is 180. Put in the 2 angles that I know, 51.59 for A, 34 for B, and solve for C. And 180 minus these 2 angles will give me 94.41 degrees for C. So now I have finished solving the triangle. I found my 2 unknown angles, and I found my missing side, so I'm done. So let's just read what we did. First, we use the law of cosines to find b. It's the only way we can find b. We cannot use the law of sines to start with. We don't have enough information for that. Once we have used the law of cosines to find b, then you probably want to use the law of sines to find either a or c. Again, it wouldn't be wrong to use the law of cosines again, but it will be easier to use the law of sines once you have found b. Finally, once we found either a or c, we find the last angle, knowing the sum of all 3 angles is 180 degrees. So we use lots of techniques here to find our unknowns, using the tool that will be the easiest in each case. All right, one more problem to take a look at, and that is example 2, solve a triangle for the SSS case. You know all 3 sides, but you don't know any of the angles. And again, only one triangle is possible in this case. There's no other way to draw the triangle other than what you see here, because the sides will determine what the angle measurements have to be. Okay, so in this case, we're going to read our thinking bubble first. First, we're going to use the law of cosines, just like last time, because we don't have enough information to start with the law of sines. But we want to be careful about which side we choose to use first, and to find that missing angle. So first, use the law of cosines to find angle B. We're going to find this angle first. We don't know any of the angles yet, but we're going to choose B because it will have the largest angle measurement. And that means the other 2 angles will be acute. Why would that be important? Well, second, we're going to use the law of sines to find either the 2 acute angles A or C, since A and C are acute. Using the law of sines will return the correct angle measurement between 0 and 90 degrees. So you won't have to worry about that supplementary angle and finding the angle that has the same sine value like we did when we had more than one triangle possible. So when you're using the law of cosines to start solving a triangle that's SSS, always start with the largest angle that will be opposite the longest side. And that way, when you go to use the law of sines for your second step, you're going to be getting your angles between 0 and 90 degrees returned to you in your calculator, and those will be those acute angles because the largest angle would mean the other 2 angles would have to be acute. Finally, find the last angle using the sum of the 3 angles is 180 degrees. All right, let's step through it. So here's the 3 sides. I've drawn a picture of what the triangle in general would look like. And so I'm going to start with my b squared because this is the longest side to get this angle that could possibly B larger than 90 degrees, guaranteeing the other two would have to be 90 degrees, less than 90 degrees. All right, so plug in your numbers. Put in 27 for your B, 12 for your A, 20 for your C, minus 2 times 12 for your A, 20 for your C, cosine of B, that's what we're trying to figure out, that B angle measurement. Okay, then simplify. 27 squared is 729, 12 squared is 144, 20 squared is 400, minus 2 times 12 times 20 is 480 times the cosine of B. Next step, I'll leave my 729 alone right now. I will go ahead and combine my 144 and my 400 to get 544, minus, leave the 480 times cosine of B. Then I'll subtract 554 on both sides and get 185 equals negative 480 times the cosine of B. Then I will divide both sides by negative 480, and the cosine of B will be equal to that fraction. Now I'm going to do the inverse function to find my B, so cosine inverse of 85 over negative 480 equals B. And putting that into my calculator, angle B then will be 112.66960, blah, 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 blah. So B, that angle B would be 112.67 degrees. It is an obtuse angle, so of course we will know that the other two angles will have to be acute. If it turns out to be an acute angle, then all three angles would be acute. That makes the next step safe to do, to guarantee we're getting a correct value for the angle using the law of sines. Okay, so next step, we're going to use the law of sines. So sine of C over C, so sine of C, we don't know the C yet, over 20. That's equal to the sine of angle B, we just figured that out here, over 27, which is our B. So sine of C over C is sine of B over B. We'll set about solving this equation now for our angle C. Cross products gives us 27 times the sine of C equals 20 times sine of 112.67 degrees. Divide both sides by 27. And you have sine of C is equal to 20 times the sine of 112.67 degrees divided by 27. Put all that into your calculator and find out the sine of C is 0.6835, And then use sine inverse to find that angle C measurement. So sine inverse of 0.6835 is C. So according to your calculator, that angle C will be 43.11862, and angle C then is 43.12 degrees. Okay, so we've used the law of cosines to find angle B. We've used the law of sines to find angle C. To find our last angle, that's the last piece of information we need, because we were told all three sides. So that means we have to find all three angles. So the last angle, which will be angle B, the last angle will be angle A. We figured out B and we figured out C here. So angle A will be figured out by saying A plus 112.67 plus 43.12. That's our angle B and C. Has to sum to 180. Solve this for A and find that A is 24.21 degrees. So we have all three angles. All right, so that finishes our study of solving triangles using the law of sines, the law of cosines, and knowing that the three angles in a triangle sum to 180. And it's time for you now to move on to your next step. We'll see you next time.